Hey guys, I don't know if anybody's watching. I guess I'll just narrate a little bit. It says Professor Dustin up at the Merrimack Observatory, top of Palmisano Hall. We've been trying to get streaming up and running because of the pandemic, and we're almost there. Just doing a little bit of testing to see if we can get our telescope pointed accurately enough to look at some solar system objects. And you can see what I'm looking at now is Jupiter. So we are looking straight through a huge amount of air, and it is very windy, and so the image is jumping around quite a bit. It settles down here and there. But you can definitely see some cloud bands sort of going vertically left, upper left to lower right. I can see at least two cloud bands. I could imagine a situation if we were lucky that we would see the great red spot using this camera setup, so that's pretty cool. What I think is extra cool is that there's actually one of the moons in sight. It's right below to the lower right of Jupiter. I can play with the exposure a little. I can get the moon to pop out a bit, but that's pretty cool. Since I've been here, that moon has moved from the limb of Jupiter out. So my guess is that's Io, because that's should be the only moon that's cranking around Jupiter fast enough for me to actually see it move over the course of half an hour. I'm going to try to play with the settings a little bit, see if I can get a little bit cleaner, but at the moment we are looking at Jupiter. Yeah, that might be the best I can do. Just so low in the sky, and there's just so much air mass between us and the planet. There's not really can't get it any clearer than that. But I'm pretty happy that we can pick out that moon. Like I said, it's probably Io. So Jupiter is like a super crazy weather planet. There's two cloud bands there, so you can see the white and the gray. So the gray cloud bands and the white cloud bands move in opposite directions. There's so much Jupiter is rotating so fast that the extreme forces that create the weather we have on Earth actually make the cloud bands, instead of rotate in circles like they do storms on the Earth, they wrap all the way around the planet and go in opposite directions. They're also churning, so the white bands are falling and the brown bands are coming up. So Jupiter is constantly being mixed like this really wild, crazy place. And you can get pictures from like the satellite Juno, which is out there. Went with Galileo out to Jupiter to see the cloud bands and the intense storm activity on Jupiter. Again, this is Jupiter, and I think we are seeing the moon in the lower right-hand corner, which is probably Io. I can change the exposure time. We'll lose the clouds, but get Io. See, now you're changing the exposure time. You can see that the clouds are overexposed. But now you can certainly pick out that little dot, which is the moon Io. Io is a very exciting place too. Io is known for its intense volcanic activity. It's so close to Jupiter that the tidal forces are constantly like forcing it in one way and compressing it in other ways, and it's heating up the middle of Io and causing magma on the inside to erupt outwards. And so you can get pictures from the Voyager spacecraft or from Galileo of actual eruptions of Io. These are eruptions of like sulfur dioxide and other sulfurous compounds that erupt into the region around Jupiter and actually then fall back onto the planet of Jupiter and create this sort of like intense local space environment of Jupiter. So that's Io. I could try to maybe pick out the other moons by moving the telescope a little bit. See, if I get too far, I'll lose Jupiter. And actually, one of the things I'm trying to test now is how good our pointing is. I don't want to get too far out of frame. I don't see any other moons within the scope, within the range that I am willing to move the telescope. Moons orbit in a plane, just like everything else in the solar system. Basically orbits, all the large objects orbit in a plane, and all the moons generally do too. So I should be able to go left or right to see them, but they seem to be far enough away from the planet that we can't pick them up. Let's go back to the cloud bands image. That's interesting. I can get a little bit better color if I change it to day. So let's try that. Huh, that's interesting. That's a rather good image. Oh, you know, the shaking is not... The shaking had a lot to do with me. So that's a bit better. So a lot of the shaking had to do actually with the connection at the camera, torquing the camera back and forth a little bit. Maybe the focus could be touched up. That's quite a lot worse. I really shouldn't even be trying to play with the focus on a planet. I mean, it's much easier to get these things in focus when you're looking at a star. But that is what I have. So. Oh, we lost behind the cloud. Yep, cloud just rolled in. Sorry about that. Hopefully we'll be able to get it back shortly. Yeah, we got a pretty extreme cloud bank coming in, so we got totally covered. I'm going to quick jump over to Saturn because part of what I want to test is not actually what the image looks like, but how good our pointing is. And so Saturn is still visible. We might not get a good view of it, but I still want to test it because actually what I care about. And it's nowhere in the image. So that's a bummer. So our pointing is definitely not quite good enough. So if you give me a few minutes, I can probably pull it up. Or we might get beaten by the clouds. I would say that clouds have totally won. So I think that might be it for the night. You can hang around if you want. I'm just going to drop that into the chat. I am taking a break because of clouds. So the moon is just high enough to be visible, and so I'm going to try to grab it. Obviously, you can see that I'm not looking at it yet, so let me work a bit. All right, here we go. This is the moon. What's sort of crazy that's happening is we're getting so many clouds. The clouds are covering the moon, so you're seeing the surface of the moon through the clouds, and you can see they're getting thicker, and then they're going to get a little less thick, and it's going to come back out. So that's pretty much just what we're dealing with tonight. I'm going to work a little bit, see if I can get the image a little crisper. See, now it's overexposed because I have to, depending on what the cloud cover is, it's going to change the optimal exposure time. So, because the clouds are coming in and out, it's changing the optimal exposure time and really not making it possible for me to get a good image. Just sort of scanning over the surface of the moon a little bit, seeing what's out there. Oh, there's a nice crater. So if I might be able to change the exposure time to get a better look at that guy. Yeah, that's pretty cool. So you can see there's a central region. I guess you can't see my mouse. There's a central region right where the original impactor was, and then you can see the dust result from the impactor. The remains when the asteroid hit the moon and kicked up all the dust out into the moon's atmosphere, or near the moon's surface, and then just sprayed it out everywhere across the surface of the moon. You can see that area is lighter, and the area around it is darker. The darker area is Maria. That's old lava flows. So since this impact crater is on top of the Maria, we know the impact crater is younger than the Maria because it happened afterwards. So this is looking at a pretty young impact crater. If I had my moon map out here, I might actually be able to tell you what the name of that thing was, but I don't have it up here with me. But that is a pretty good image. obviously it's not perfectly crisp. Not least of which is because the focus it's hard to get that careful with the focus, but also it moves after I let go of it. It's got a little bit of play in it. And I'm also looking quite low on the horizon. I'm still looking through quite a bit of air. So let me sort of scan around a little bit, see what else we can find. Oh, there's another impact crater. Down's a little hard to tell what's going on. It definitely is lighter in the center. You can see the darker Mari around the outside, but it's on top of some lighter material as well, so it's hard to sort of gauge. And now we're losing it a little bit because the fog, because the clouds are coming in. Yeah, it looks like the next couple minutes are going to be a little rough, but it should clear up after that. Feel free to drop any questions in the chat if you like, or just sit there and enjoy. I'm mostly doing testing of this thing so that we can know what it's about and we know what we need to do to make it work well in the future. And so now the clouds are just totally covering the whole thing. I'd say that didn't help much. Let's just get rid of that. All right, let's try to scroll around the moon a little bit more, see if we can see anything else now that the clouds have passed. that's interesting. So I don't know what those bright spots are, but presumably what we're looking at. Let's see if I can get a slightly better focus. Yeah, it's tough. So presumably what we're looking at is the dark Maria, these old lava flows with these bright spots on top of them are where presumably there were impactors after the Maria flowed over the surface. It could also be that those are high points, highlands that were above the level of the Maria when it started flowing through the area. You can see in the background there's a lot more of the highlands where the lava flows didn't make it. We're getting clouds again, naturally. One of the things that's really cool to look at on the moon is the limb, right where the shadow of the sun, of the moon on the sun side happens. So you can look right at that and look at the dividing line between the light side and the dark side. But it's nearly full moon tonight, and so there shouldn't be much of a limb. Maybe if I can scroll around the edge, you can start to pick out some other features. Yeah, so when you look across the surface of the moon like this, it's difficult to make out any real structure because you're looking at so much more distance. Also, I'm having trouble with the controller. It's completely left, right, and up, down, inverted. Oh, that's interesting. Look at those. So look at those circles. So definitely this is an example of, you can see that those must be impact craters and there's Maria inside them, so they must have impacted it at a time when the moon was still molten enough inside that the lava was able to fill up those craters. But also there's Maria around them, so there's any number of possible histories here, because typically we think of Maria as being much younger than the highlands because the Maria is the volcanic magma that rose up through the center. So maybe this could have been a very, very deep region. This whole dark region here could have been a very, very deep old impact crater that the Maria flowed into, and then further craters fell onto that Maria, so they were superimposed. Or maybe some kind of Marsquake, some kind of moonquake happened that opened up a crack so that this existing region could have filled up with magma. That's really interesting. I don't know. I wish I had a moon map. We could try to figure out what you're looking at. So if people are joining now, I'm just sort of testing out the equipment for the Merrimack Observatory stream sessions, and we're just checking out a live image of the moon. It's a very bright moon, so it's hard to keep in focus, and also I'm looking through a lot of air because the moon is very low on the horizon, but just sort of scanning over the surface and looking for any interesting things we can find. There's a very large dark Maria region there. Looks like on the edge of, if we give it a minute, the camera should adapt. There's a large impact crater on the side, and then going up towards the highlands there. Now we're at the edge of the moon, so I'll try to just sort of go around it. Well, that's pretty interesting. If you look at the very edge there, so I think that's the shadow. So it's very, very close to a full moon. I'm not sure about that. I'm just sort of guessing the top there is the shadow, but you can actually see the mountains. So there on the moon is not really mountains. They're sort of most likely due to impact events, but they could be mountains because there's no tectonic activity on the moon, so you can't get the kind of plate collision. But it did have an early, very active history, so mountains could have been formed in any number of ways. It's likely those are related to impact craters, but you can see there's at least two of them there, just peeking over the shadow there. That's what I mean. It's much easier to see that kind of stuff when you've got the shadow of the sun to help you. And you can see some Maria behavior in the front here. Let me go over the top, see if there's anything else you can see. I mean, that's a great view of a crater there as we're coming over the top of the moon. Yeah, it's looking at edge on onto a bunch of craters over there. Yeah, so this is definitely the edge of the shadow. You can tell that instead of being a sharp edge, this is the shadow region. We're on the other side. You know, the sun is behind us, right? So the other side is the shaded part of the moon, the part that the sun isn't hitting at this particular moment. I guess I might try to play with the exposures a little bit and try to see if I can clear up that front section. Yeah, that's a bit better. Then it saturates. So there must be some kind of auto being set somewhere, which is messing up the balance. That could be it. Yeah, this is just some calibration stuff. That looks like a pretty good image. I don't really know what those settings mean. This is also part of the deal, so I don't really know what I'm doing here. That's sort of interesting. Now you can sort of pick out the craters a little bit. Let me keep it in that setting and zoom around, see what we see. Yeah, the camera is doing some kind of calibration, which I'm not a fan of. So when I saturate the image a little bit more, yeah, it picks out the surface details a little bit more. So I just have to figure out which auto image, what automatic thing is happening there. But lots of craters. It's definitely a highlands area. I don't see any Maria, so this is a very old region of the moon. Generally, older regions have both large and small craters. Large craters have often been filled in by the Maria, so this region must be pretty old because it has both large and small craters. Also, earlier in the solar system, there were more large objects floating around in order that could land on places like the moon, and so places with large craters typically are older surfaces. So the moon is 4.5 billion years old, so a little older than the Earth, and so this is probably part of the oldest part of the moon. It had solidified already, so it must be a little younger than that, but nevertheless, this is quite an old region. Oh my god, what direction to go in? There we go. Yeah, some of those, you can see into those craters. See, there's a shadow being created by the light of the sun. There's a shadow falling inside that crater. That's pretty neat. All that stuff over there, yeah. Of course, there is a dark side of the moon. We are looking at the light side right now, the dark side being the stuff on the other side. But it's actually, because of the moon does wiggle a little bit as it faces us. Those are called libations. And so as the libations happen, you get a little bit more sun on one side and a little bit more sun on the other. So you actually, from the Earth, you can actually see a bit more than only half the moon. But of course, at any one given time, you can only see half of it. And generally, I think the total amount of the moon that we can see is something like 60% at any given time. So there is definitely the notion of the dark side of the moon, even if it's more fanciful. Yeah, some of that edge-on crater stuff, which is so cool. Yeah, if I go back into the center, I should get that correction happening. Yeah. And so this is about where we started, actually. Okay, guys, I'm going to move away from the moon just because, that is pretty cool. I mean, it's just like staring at a zoomed-in map. You can kind of get lost looking at all this interesting stuff. There's some of those very small craters on top of Maria. Okay, so looking up the sky. It's possible we could try for the ring, but one of the major things I wanted to test is actually the pointing accuracy. So right now what I'm going to do is I'm going to go to Saturn. Hold on, let me see. Make sure there's no clouds over there. I can't quite see from inside the dome, but I think it's pretty cloud-free. So we're going to move to Saturn, mostly as a test to see how good the pointing accuracy of the telescope is. So give me a few minutes and I'll come back. There it is. Great. So the accuracy wasn't great, but I was able to find the right spot. Whoa, there is Saturn. That is a pretty good image. I think I am pretty happy with that. Again, the bounciness, it's pretty cool. You can actually see you can't see the division between the rings, but you can see the separation between the planet and the rings quite well, actually. I think I'm happy with that. So I guess I'll talk a little bit about Saturn since we've got some people who are watching. So Saturn is a gas giant planet. It's after Jupiter. So Mercury, Venus, Earth, Mars, asteroid belt, Jupiter, Saturn. Saturn is the second most massive planet. Forget the fraction of Jupiter's mass to Saturn's mass. Saturn's very low density, so my feeling is that it's probably about half the mass of Jupiter, but a little bigger than half the size. If anybody knows, drop down in the chat. It's got rings, obviously. The most important aspect of Saturn is that it has rings. It's also very low density, like I mentioned. I think I've heard this, that if you could put Saturn in a bathtub, it would float because it's less dense than water. It's the only example of a planet that's true about that. The rings are made of mostly icy particles and dust grains that have mostly, so these big rings have formed early in Saturn's history, but the rings are gradually falling down into the planet and being replenished by the moon system. Saturn has tons of moons. I think it's the highest in the solar system right now at like 85 or something, and more are being discovered all the time because basically Saturn is just surrounded by these rocky bodies that are left over from the formation process of Saturn. Let's see, what else? Sometimes you can pick out Saturn's moon if you are Titan. If you are, if you've got a nice big telescope, we can see it in ours. I don't think you'll be able to see it on this image. I was looking at Jupiter before, and I could see one of Jupiter's moons. It's a little bit harder to pick out Saturn's moon sometimes, and I don't really know the settings, our system well enough. I'll just look around a little bit. Saturn's moons orbit in the same plane as its rings, so I'm just going to try to move up and down. And if we see any, that might be it. Yeah, that might be Titan. So Saturn is now in the upper part of the image. You can see just in the lower left, there's a little very dim dot. I'm guessing that is Titan. It's kind of a guess, so don't write home about that or tell somebody that Professor Dustin said something totally wrong, because it could be totally wrong. Yeah, and there's nothing else seems to be in the immediate vicinity, so my guess is that is the Titan. So I want to play around with these settings a little bit. It's recommended to use something called a Barlow Lens when you look at planets, and so I'm just going to pop one in and see how that helps the image. It will zoom it in quite a bit, but it might distort it so much that it's not worth looking at anymore. getting the focus on this thing hard is really, really hard because the focus is way on the other side of the room, so I have to look at the screen to see the focus. So now I tried to focus it, I come back over, I can see it's clearly not in focus. Yeah, I'm not sure what the right combination of settings is for this guy. Sorry, it's extremely difficult to get into focus, even when it's not bouncing around. So I think even if it was in focus, it probably would be a better image. But it's also, it's pretty tough when you're zoomed in this much to really, and you're looking with this kind of system. I mean, we are right near Boston. We are never going to get a very nice night, and a night like today, which is windy and cloudy. I mean, I'm glad that I can see something, but I wish it could get clearer, but I don't think I can do any better than that. I don't know, I guess I could talk a little bit more about Saturn. It's funny, I'm not a planetary astronomer by trade, so, I studied stars, so every time, I basically learn all the planetary stuff. Every time I have to teach my astronomy class, I learn it again. We're doing Saturn next week, so I'm not totally boned up on my Saturn knowledge yet. But so we first saw Saturn, Voyager 1 and 2 spacecraft in the 70s and into the 80s. We've also sent Cassini there recently, which is a satellite that, I think Cassini is the one that plunged into, oh no, I'm sorry, that's Galileo, sorry. Cassini is the one that visited Saturn, took nice, great pictures of its rings and all the little bodies that are around Saturn. Saturn is predominantly hydrogen and helium gas. The inside is very likely some kind of metallic hydrogen, extremely high pressure fluid, which is generating the magnetic field of Saturn. The same thing is true of Jupiter. Those two planets are the only ones that are thought to have that magnetic hydrogen material in the center. Uranus and Neptune probably don't, or probably not massive enough. I don't know, I'm just rambling now. Okay, so I think I'm just going to look at one more object. This is going to be my reach object. Oh, of course it's super cloudy now. Yes, it did get super cloudy up there. Well, we might be able to try it. So the thing I'm going to try to look for is the Ring Nebula. This is basically one of those faint fuzzies that astronomers try to look for all the time. It's actually relatively bright. You can see it in a regular telescope, but this kind of system, is, since it's integrating over time and picking up a lot of light, it can also stack images on top of each other. It might have the possibility of getting us a really good image. So I'm going to try to point this thing at the Ring Nebula after I take out the Barlow. Focus just in case I need it. And we're back to that relatively in-focused image of Saturn. And I'm just going to blindly tell my telescope to go to Vega, or not to Vega, sorry, the Ring Nebula, and let's hope it works. Well, I don't see anything. such luck. Oh, that might be it. No, I don't think so. Yeah, that's too bad. The pointing is just not good enough. And of course, this is not the situation we want when we do real live streaming. We don't want to have a bunch of dead silence while the lucky astronomer randomly scans around the sky for anything. So the issue is that the computer and the telescope mount, you know, they know where things in the sky are, but of course we have to calibrate it, and normally we calibrate it visually because that's predominantly what we use the telescope for, visual observations. But in the camera, the field of view of the camera is very, very small, and so when you use a visual observation, you got a big eyepiece to look at, and if you're not quite on, it doesn't matter, you can just move. If you know what you're looking for. But for something like this, where we're looking for a very dim object, and the pointing is not quite as good as it is because we've got this little tiny field of view, it just becomes very difficult. Yeah, I think I'm going to call it a night and decide that we are not going to be able to see the ring tonight. Sorry about that. So I think I'm going to call the stream. Thanks for everyone who attended. This was really just a test. Hopefully we'll have a better time, better experience, and better weather, of course, when we get around to actually doing official live streams, which we will post on the Facebook page. We're going to try to do live streams on YouTube so that you don't have to log into Facebook to see them, and we'll post information about that here. As you probably know, Wednesday nights are when North Shore Amateur Astronomy Club runs our dome, and so we really have regretted not being able to do that. So I think our first thing we'll try is maybe some Wednesday night sessions with me and a student or something like that to get that started. Then maybe we can somehow get them back on campus, maybe next semester. Or maybe we'll do some remote thing where they talk about the objects and we control the telescopes. We don't know. So in any case, thanks for watching. I'm going to start shutting down the dome. Drop any comments you have about how this went. Of course, this is not really how it's going to go. Hopefully it will go better. But if you have any comments for us about how you think we can make this a good experience, please let me know. Okay, great. Thanks everyone for watching. I'll catch you next time. Okay, I lied a little bit. I'm actually going a little bit more. Just noticed that Jupiter's out. So I did want to try something. If I can easily get Jupiter in the image. Oh, there it is. Massively overexposed. Jupiter and the moon. Okay, but now I want to replace it with a focuser, which should give a better image. Ah, can't focus enough. Ah, that's interesting. Okay. Can't use the focal reducer because our telescope doesn't, the focus doesn't go in far enough. Focal reducer. Okay. don't think anybody's still watching, but I'm going to actually end because I am actually done. Gotta get out of here. Thanks, everyone. Goodbye.